What is up, Algebra 2 students? This is lesson 55. Our objective is how do you find abstract solutions and then also use quadratics in word problems. So we'll do the first one, we'll do an example for each. Abstract solutions are whenever you're working with things like this that are just full of letters. So they're not really numbers, and so it's hard to be like, oh, this is where I could use that. That's why they call it abstract. But really, we're still going to use the same properties that we would solving any other equation. It's just going to be all with letters, so the stuff doesn't simplify down as easily. So the first thing I guess I'm looking for is it says solve for m. So I remember, or I know that my answer is going to be m equals something, right? Blah, blah, blah. So notice this m is on top, right? This is over 1. And right now my m is on the denominator, so I have to get rid, or I have to move this m from the denominator up to the numerator. And while I'm at it, I'm going to go ahead and get rid of all my fractions. So what I'm going to do is I'm going to multiply this left-hand side and the right-hand side by xm. I'm not, trying to advertise Sirius Radio or anything like that. So multiply both sides by xm. So that way all my fractions will reduce. Whenever I multiply it by this one, the x's would reduce, and I will end up with m times a plus b. When I multiply it by that one, the m's reduce, and I end up with xy. And over here I just end up with a kxm. Now distributing this, I end up with ma plus mb plus xy is equal to kxm. Alright, now my goal is going to be try to get everything with an m to one side and everything without an m to the other side. So what I'm going to do is I'm going to go ahead and subtract a couple of ways. I'll just go ahead and subtract ma minus mb minus ma minus mb. And since those variables don't match up exactly, I can't combine them together. This part all goes to 0. So I'll end up with xy is equal to kxm minus ma minus mb. Now why I did that is look over here at the right. What do all three of these have in common? The only thing they have in common is an m. And so I'm going to factor that out. I'm going to say m times kx minus a minus b is equal to xy. Now all I have to do to get m by itself is divide by that big monstrosity. I'm just not going to write it to save time. And then that would reduce with that. And I would just end up with an m is equal to, well, there's an xy on top. On the denominator, I have kx minus a minus b. And that is my answer because it says m equals something. Okay? Alright. Let's work with where we might have to work with a quadratic in here. It says find 3 consecutive integers such that the product of the first and the third is 4 greater than 4 times the second. So let's go ahead and start off here with I'm just going to say my smallest integer is n. That means my second one is going to be n plus 1 because it says consecutive integers. And I'm looking for 3 of them, so this is 1, 2, and the next one is going to be n plus 2. So these are my 3 consecutive integers. So it says such that the product of the first and the third, so the product of the first and the third is going to be n times n plus 2, so my first and third, is 4 greater than 4 times the second. So this is 4 times the second. And then 4 greater than that would be plus 4. So now I have an equation from the words, and now I just need to solve that. So let's go ahead and multiply this in. This is going to be n squared plus 2n. It's going to equal to 4n plus 4 plus 4. Those two is just 8. So I'm going to subtract 4n and subtract 8. And I will end up with n squared minus 2n minus 8 is equal to 0. So now let's try factoring this, because that's the easiest way to solve probably. End up with an n and an n. Factors of 8 that subtract to give me 2. Well, 4 and 2 multiply to give me 8. It's going to be a minus 4 and a plus 2. So now solving this, either n minus 4 is equal to 0, or n plus 2 is equal to 0. So that means n is equal to 4, or n is equal to negative 2. So what does that mean? So here is an answer, or here is an answer. Since we end up with two answers, there's actually two different possible answers to this. The first one would be 4, 5, and 6, right? Because I'm doing it back to here. That'd be 4, 4 plus 1, and 4 plus 2. That's how I got the 4, 5, and 6. So there's one answer. Or the other option would be to say negative 2 plus 1, negative 2 plus 2, which would be negative 2, negative 1, 0. So those, in this case, actually end up with two possible answers. And you'd want to include both of those in your homework. Your homework is there on page 233. You're going to do 1 through 3, 5 through 10, and then 6 more of your choice.